to 8,000 papers are uploaded daily to PubMed. So it's impossible to follow. And it was the same in clinical science. You could see how many new techniques available nowadays. It's also not possible for a basic scientist to follow what's happening in there. So finally, the two categories went away. If somebody finishing the medical school, you have two choices: go to be a clinical doctor or go to be to the Department of Physiology, Anatomy, and start doing basic research and never meet the patients. And what did it actually resulted? That even more billions of dollars spent on research, much less come out each year in science. Therefore, first, in the United States at NIH, they established the word like translational medicine, in which there is a third category which can translate between the basic and clinical scientists, so bring the clinical idea down to the lab and bring the ideas back. And of course, all pharmacological or therapeutical development, the results are much better if they results coming from the knowledge of basic science. It's definitely for sure that in almost all universities in 20 years' time, there will be translational medicine department who will actually run science. But nowadays, if I look at where we can meet actually a center for translational medicine, only in the biggest universities. And actually last year when I came here, I came from Szeged, but this year I came from Pécs, because the University of Pécs offered a fantastic opportunity to establish the first center for translational medicine in Central and Eastern Europe, in which there are not only clinical or basic science, but we can put them together. So how our Center for Translational Medicine look like? We have a Department of Translational Medicine, there are vets, the patients suffering from acute pancreatitis admitted to this department. We have an Institute for Translational Medicine, which is actually a former department of pathophysiology, was in Pécs, and we do the basic science part here. However, and very, very importantly, and in many places we miss very much for clinical science, we established a multidisciplinary research group. And how this multidisciplinary research group stands, because usually when you do science, you are alone. But this is not sufficient, because if you run trials, you need electronic data management systems, you need IT persons developing the background for your trials. Of course, clinical data quality are also very important, and those who can actually make the ethical approvals. So we have now an operative data and clinical studies group. And finally, you also need really excellent biostatistic groups who can do all the data analysis. And of course, you need a media group who can transfer your funding to the patient. So nowadays in Eastern and Central Europe, we do everything. But of course, if you would like to do professionally what they do in the West part, you need these kind of parts. And we were very lucky in Hungary that the University of Pécs started this. So what is translational medicine? Have a question in clinical science, go down to the lab, bring back your knowledge to clinical science, and start thinking how I can interfere what I found in basic science. Let's try to develop some new treatments or new drugs and bring it back to clinical science. So let's look at, of course, my field is pancreatology, and although we would like to extend this to the other part of GI and also to other medicine, of course we focus mostly on the pancreas. Let's look at the pancreas, acute pancreatitis. The incidence rate actually continuously elevating, and as we heard in the first presentation, this is one of the most common GI disorders needing hospitalization, and is still a severe disease. In the severe acute pancreatitis, the mortality level is still 30 to 50%. Unfortunately, this is an excellent place to do translational science, because until now we don't have any specific therapy for the disease. So as I said, translational medicine, starting from the theoretical departments. let's look at the physiology of pancreas. It's always important to understand the physiology and anatomy of the cells of the organ, otherwise you can't go further. So the exocrine pancreas contains two main cell types. One of them is the acinar cells, and the other the ductal cells. The acinar cells secrete over 300 bioactive molecules, and the ductal cells secrete 1.5 liters of fluid with 140 millimolar bicarbonate concentration. So this is a 1.5 liters of protein-rich, high bicarbonate concentration fluid. Of course, it needs huge amount of energy, because in the blood there is only 25 millimolars or 24 millimolars of bicarbonate concentration. Reaching such a high level, you need energy. So let's, from the Department of Physiology, move to the Department of Anatomy. What's happening in the anatomy? Of course, when we looked at the electron microscopy pictures of the cells, you can immediately see that here are actually the ductal cells, here are the nuclei, and look at like these small dots, and also in the acinar cells there are huge amount of mitochondria inside the cell, and they secrete large amount of ATP. So if I would like to summarize about the physiology and anatomy, this is a cell type, this is an organ which needs lots of energy to provide the basic functions. Okay, let's move further to pathophysiology. How we can induce actually pancreatitis, what are the etiological factors, and actually the two main etiological factors are bile and ethanol, and of course fatty acid as well. So in all ways, in basic science, we try to mimic the human situation. So what we did about the experiments here, we try to mimic the situation when the Oddi sphincter is closed and the bile can reflux to the ductal system. So we isolated the pancreatic ducts, and after with a small cannula we just put bile into the system. And what about the pathology? When we look at the pictures on electron microscopy, we could see that when we gave cannabidiol, which are bile acids, to the cells, what we could see that almost all of the mitochondria swelled up, disappeared, and the cell's ATP concentration dropped down. So if I look at about the pathophysiology, how the disease developing, we can see in a very early phase a clear mitochondrial injury, a clear ATP depletion, and of course if the cells no ATP, the cells cannot secrete bicarbonate any longer via the CFTR chloride channel, and also they cannot secrete the pancreatic enzymes in an inactive form, and the pancreatic enzymes stay in the pancreas, acidosis starting, and the autoactivation of trypsinogen starting, and the disease start developing. Let's look at how the alcohol and fatty acids induce pancreatitis developing. And I usually tell to my students that read old papers, because as I said, the boom in science happened in the 70s. And there were plenty of fantastic observations before the 70s when the clinicians observed the problem, but after they left it unattended because there were no techniques to look at. And after nowadays, nobody reads papers from the 50s and 60s, although there are plenty of new ideas can come out. And actually this is one of the papers we found in the past which had an absolutely brilliant observation, which was Henri Sarr, maybe the older pancreatologist remember the name, who was a very famous pancreatologist from Marseille, and he tried to understand the initiation of pancreatitis, that what is the very early sign during the acute pancreatitis, and he looked at different forms of pancreatitis, but what was common in them, that almost all of them were alcoholics. So the results maybe reflect the effect of alcohol. So, and what he found, actually, before any kind of alterations, any kind of ductal irregularities, pseudocytes, anything, the very beginning was actually a small mucoprotein gel inside the pancreas. So before the 70s, CFTR chloride channel was not discovered, but they knew that in kids in cystic fibrosis, they have exactly the same results. And that time, and also nowadays, the diagnosis of cystic fibrosis is measuring first the sweat chloride, and that time they also measured the sodium concentration because they didn't know that the CFTR chloride channel is responsible for the disease. And what they found that actually about the controls in pancreatitis, actually the sweat chloride concentration elevated. So what they said immediately, that this is something like a very complicated issue, like an adult mucoviscidosis, but because they didn't know anything about CFTR, which was discovered 26 years ago, they just left it unattended. However, when we read this paper now, we immediately can think that maybe ethanol has an effect on CFTR, and ethanol modulate inhibiting the CFTR chloride channel, which result the cystic fibrosis phenotype. So actually I have really clever students in my lab, and I ask them, how can we look at whether ethanol has any effects on the CFTR chloride channel? And they immediately meant it's very easy because the students also like going to pubs. So if somebody is drinking alcohol, it's very easy. After, let's measure the sweat chloride concentration. So we prepared the study. Actually, we got the ethical approval for 10 volunteers to drink alcohol. And actually, I said to my students, let's find some volunteers to join to the study, and all of them were smiling because from the 10 volunteers, from 9 already were signed by my students. So they immediately said that I must be the 10th of this test. So we had to drink 400 milliliters of vodka within half an hour. Yeah, it seems get the point. When I had this presentation in Moscow, it was so quiet, and somebody asked, yes, this is the control group, but where is the treated one? But it's definitely, actually in Hungary, this dose was definitely the treated groups. So actually, the lab was absolutely happy. We never ever planned any such a study where everyone was smiling. However, the sweat chloride concentration didn't rise at all. So immediately, my students said, okay, if this study was not successful, let's repeat it. So, and I said, okay, it's a very good idea. However, if I send the bills to the Hungarian Academy of Sciences every week about from vodka, maybe it's not good. But maybe in Hungary we can find some really professional drinkers who usually admitted to the ER unit. I don't know whether in Romania they are existed, but in Hungary that's for sure. And they were admitted to the ER unit, and actually they could reach over 100 millimolar ethanol concentration. We could reach only 20 after 4 deciliters of vodka. So they drank over 2 liters, and we were surprised that they survived. But the sweat chloride concentration was elevated, showing that almost the CFTR chloride channel was totally blocked. And when we followed these patients and we measured actually the sweat chloride concentration, it decreased. So we definitely realized that alcohol definitely decreasing the activity of CFTR chloride channel, which works after phosphorylation, which needs ATP. So we went back again to the intracellular mechanism, and we again looked at how CFTR is blocked, and we found the same, like in the bile-induced pancreatitis, that fatty acids, ethanol, actually damaging mitochondria, decreasing ATP, and if you decrease ATP, the cell cannot exude calcium from the cell, stop the CFTR chloride channel, and actually the exocytosis of the bioactive molecules. So what basic science telling us in pancreatology? It doesn't matter what is the etiological factor of pancreatitis, the mechanism, the very early mechanism, the first 6 or 12 hours, actually exactly the same. Severe mitochondrial damage and energy depletion with the calcium overload. Okay, so the question is, if this is the first sign in pancreatitis, what's happening if you give ATP back to the cells? So we designed the next part of experiments with the Liverpool World Group, where Ole Petersens and the others are there. So here you can see a toxic calcium signal when the calcium can go away from the cells. So when we gave ATP with a patch pipette directly to the cells, again an oscillatory calcium signal came back, so the cells started working again, and you could see that the death of the cells depend on the extracellular calcium. When we give ATP, it's depleted. This is like the CFTR chloride channel. This is a forskolin activated channel, and this is actually like fatty acids or ethanol decreasing the channel activity. When we started giving ATP back step by step to the cells, the activity of CFTR chloride channel started recovering. So it's almost the same like a patient who is in a clinical death level. If you start interfere in very early during the damage, you can make the cell survive, and you most probably will have less necrosis. So what are the benefits of thinking this translational science? Of course, this is a benefits for the patients, which is very good might be at the end, but also benefits for the scientists, because if you put a translational project together where there are patients and there are basic science, you can publish your articles in a much higher level of impact paper. So all translational working actually in the last couple of years, in all last 10 papers published from our work group, we could reach really a high level of journals. And we know that gastroenterology is the highest ranked journal among the GI field. This is the centers who could provide papers to gastroenterology, and finally using this level we could reach. There is no miracle in it, just the thinking started in clinics, and we actually, who understood what is in the clinics, developed actually the issues. Okay, so the next question is how to make it benefits for the patients, and plenty of people thinking that only new drugs can be useful to help the patients. But if you think there are still possibility to drive energy back to the patients, for example, enteral nutrition, which is one way. We also have like parenteral nutrition or glucose or insulin injection to the patients. All of these can drive energy back to the cell. But I always ask whether is it useful actually to think in a translational ways, and I must say yes. For example, the Dutch pancreatitis study group, which is one of the most known, well-known pancreatology group, and they publish in New England, JAMA, Lancet, in the best journals, they also ask the questions whether if we start in an early nutrition, whether it's helpful for the patients or not. And they organize a study concerning that early versus on-demand nasoenteric tubing feeding in acute pancreatitis. However, if you look at their figures about the amount of calorie delivered to the patients, this is the early, they started this building up, and this is the on-demand. Neither of the patients got normal amount of energy on the first day. It's the same like in stroke, if you start the thrombolysis on day 4. Nothing will happen. So, and they ended the study that actually there is no difference between early enteral feeding and late. But this is not early enteral feeding, this is early enteral tubing, because the enteral feeding started only the 3rd day.